Good morning, everyone. Today we are going to start chapter number 7 events from subject web frameworks. These are the contents from the chapter number 7, that is asynchronous JS, asynchronous control flow with callbacks, promises, then event emitter class, asynchronous and await instruction, then returning event emitter, inheriting events. So first we will see asynchronous JS and asynchronous control flow with callbacks. So we'll start with asynchronous JavaScript. So JavaScript is a single threaded programming language, which means only one thing can happen at a time. In first chapter we have seen that JavaScript is a single threaded programming language. So that's why it can execute only one thread at a time. That means this programming language only it can be happen that only one thing can be happen at a time. That is, the JavaScript engine can only process one statement at a time in a single thread. In a single thread it can execute only one statement at a time. So while the single threaded languages simplify writing code because you don't have to worry about the concurrency issues. This also means you cannot perform long operations like network access without blocking the main thread. You cannot perform the that long operations like that net if you have to access that network without blocking. We have seen that IO blocking and non-blocking. That is, without blocking the main thread, you cannot perform that kind of task using single thread. So here, imagine requesting some data from an API. So depending upon the situation, the server might take some time to process that request while blocking the main thread, making that the web page unresponsive. For that, it will block the web page for some time so that it can access or it can process with that request. So here that is where asynchronous JavaScript comes into picture here. So using asynchronous JavaScript like such as callbacks, promises and asynchronous and await instruction, we can perform long network requests without blocking the main thread. Using that asynchronous callbacks or using asynchronous JavaScript, we can perform this long network request without blocking that main thread. So here you can see the example, that is how does that asynchronous JavaScript work here. So what is blocking here? So for that there is one example here you can see that this example here for that is if we are doing an image processing or network request in a synchronous way. This is the synchronous way. Here you can see that constant process image. We are going to process the image or performing some operations on that image here. Then we are going to print one message using console.log, that is image process. Then we are going to start that network request using URL, that some network related or that requesting network resource here, then returning some data from that request, and here greeting function, that is constant greeting. In that we are going to print one message hello world, and now another function, that is process image. In that one image is there like logo.jpg format, then network request and URL is there, and at last we are going to call that greeting function. Okay, so what is blocking and how this network request will be processed in synchronous way? Here, doing image processing and network request takes time. For image processing and network request, it takes some time. So when process image function is called here, when process first it will call that when process image function is called, okay, it's going to take some time depending on the size of image. Based on the size of that image, it will take some time to process that image. So when the process image function completes, it is removed from the stack. We are having one stack. When that process image function completes, it's removed from that stack. After that, the network request function is called and pushed to the stack. After that, here you can see, after that that network request function is called. Okay, so after processing this function, it will remove from the stack, then next function will be pushed into the stack, that is network request. Okay, so again it's also going to take some time to finish that execution. Okay, So at last, when that network request function completes, here the network request function completes, it will pop up from the stack, or that greeting function is called here. Next function is greeting function. Okay, after network request, greeting function is there. That greeting function is called, and since it contains only a console.log statements, here you can see after that greeting function is called, this greeting function is called, it takes what it contains only a hello world message, that is only console.log statements. So that statements, these console.log statements are generally executing fast, so that that greeting function is immediately executed and returned. So if you see, we having we have to wait until the function like process image or network request has finished. This means these functions are blocking the call stack or main thread, so we can't perform any other operations while that code is not executing, which is not ideal here. So we have to wait here for executing. We have to wait for some time for executing this process image and network request function. So this is the sequence, uh, synchronous way of executing this code here. Okay. So what is the solution for this? So the simplest solution is asynchronous callbacks for this. So we have to use asynchronous callbacks to make our code non-blocking. This is the blocking. Okay, here blocking. So this process image and network request function will block that main thread. Okay. So solution for this, we have to use asynchronous callback to make our code non-blocking. Here you can see the example where having we are going to use the callbacks here like set timeout. Here see the example, constant network request having set timeout method with the callback and that timer here console.log asynchronous code, and we are having timer here, and we are going to print the hello world message and call that network request. Here you can see we have used set timeout method to simulate the network request. Here keep in mind that set timeout is not the part of that javascript engine. Okay, it is not part of that. That's this set timeout method is not the part of javascript engine. It is part of like this web apis for the browser, or that c or c++ apis from node.js. Okay, so to understand this, how this code is executed, you have to understand some concepts like event loop, then callbacks, callback queue, that is message queue, or also called as task queue, web apis. Okay, here you can see that call stack, we are going to push that method into that call stack. Okay, see the message queue contains some callbacks, events. These are the web apis we are going to use. Okay, here that event loop and this web apis, event loop, yeah, event loop, web apis, message queue or task queue are not the part of JavaScript engine. It is a part of browser's JavaScript runtime environment, or it is a part of Node.js JavaScript runtime environment. Okay, in Node.js, the web APIs are replaced by C or C++ APIs. So see this code, how is this code is executed in asynchronous way. We have seen this code for non-blocking here. So we will see how this code is executed in asynchronous way. That code is, we are having one network request method with a set timeout method having callback and with timer. Then we are going to print one message, and we are going to call that network request method, and at last we are going to print that end message. So how it is executed here, you can see when we are going to load this code in the browser, that the console.log hello world, here first it will execute this statement. Console.log is pushed into the stack and pop off the stack after it's finished. Whenever it will finish the statement, first it will push this statement into stack, and after executing it will pop up from the stack. And next one is network request. After executing this console.log hello world statement, it will uh, call the next, that is call to the next network request is encountered, so it's pushed to the top of the stack. Now in stack that network request method is there, so that network request method having set timeout and one console.log statement, so that whenever that set timeout function is called, so that it is pushed into the stack, and it is having two arguments, that callback and time. Here this callback and time we are having for that set timeout method. So that set timeout method starts a timer of 2 seconds. Here set timeout method having timer for 2 seconds in the web API environment. So at this point the set timeout has finished and it's pop up from the stack. After it, it will print the console.log statement in the stack, and it will execute and remove from the stack after its completion. That is the end statement. So meanwhile, the time has expired. Now the callback is pushed to the message queue. After executing all the statements, this callback is pushed to the message queue. But here the callback is not immediately executed, and that's where the event loop kicks here. That call now, after executing all the statements here, after executing all the statements, these callbacks are pushed into the message queue, but that callback is not immediately executed, and that is where the event loop kicks here. Here we can see that event loop here. After executing all the statements in the call stack, and after that call stack is empty, that callback are in message queue. That's why that event loop is here. Okay, so what is that event loop? Here the job of that event loop is to look into the call stack and determine if the call stack is empty or not. It will check, event loop will check that. Here event loop will check that call stack is empty or not. Okay, so if that call stack is empty, it looks into the message queue to see if there is any pending callback waiting to be executed. If it sees that that call stack is empty, it will look into that message queue, that is there any callback is present in that message queue or not. If it is there, it will execute this callback here. So in this case, the message queue contains one callback. We have seen that message queue having one callback. Okay, so and that call stack is empty at this point, so the event loop pushes the callback to the top of the stack. That means after that console.log, here this callback is pushed into the message queue. After that, it will push into the call stack. Okay, so it push to the top of the stack and execute and pop up from the stack. So at this point the callback has finished, so it's removed from the stack and program finally finishes. Okay, so in this way we have seen uh, how that callback works here. We are going to push all the instructions functions into the call stack and executing one by one, and at last we are going to push that callback into that message queue. That event loop will check here if that call stack is empty or not. If it is empty, it will look into that message queue. If that message queue having any callback, it will push that callback into the call stack and execute that callback and pop up from that call stack. Okay, and finally we are going to finish that execution of that program. Okay, so that is for that event loop here, how that event loop works here. Okay, so the next point is asynchronous control flow with callbacks. So that default way of Node.js that handles asynchronous functions by registering callbacks. They handles asynchronous function by registering callbacks that should be executed once and asynchronous function is completed. That should be executed once and asynchronous function is completed, but without a lot of discipline, a developer risks falling into the trap of the callback hell of highly unmaintainable and unreadable code. So that asynchronous functions are handled by registering callbacks, so that should be executed only once here. So for handling for that asynchronous control flow with callbacks, we are having some callbacks, function sequence control. Okay. So first we'll see what is callbacks here. What is JavaScript callbacks? So a callback is a function passed as an argument to another function. callback is a function passed as an argument to another function. We are going to pass function as an argument to another function here. So this technique allows a function to call another function. Function calling another function here as an argument. So a callback function can run after another function has finished. So what is the function sequence for that? So we know that JavaScript functions are executed in the sequence they are called. Functions are executed in the sequence they are called, not in the sequence they are defined. Here you can see first we are going to define the my first function, then we are going to define the uh, function my second, so that JavaScript does not execute it like that they are defined. They are executing like in the sequence they are called here. Okay, so first it could call my first, then my second. So it will first it will push that my second function into the stack, so it will move towards the my second function. It's having my display function with the statement goodbye. So first it will print goodbye statement here. Okay, here this example will end up by displaying a goodbye statement. Okay, if that my first function is present at last, so it will execute first my first function. Okay, so it will print hello. Okay, that means JavaScript functions are executed in the sequence they are called. Okay, so next one is sequence control. So sometimes you have you would like to have better control over when to execute a function, when to execute a particular functions. We have to control that sequence. So suppose if you want to do calculation and then we want to display the result, so first you could call a calculator function like my calculator, then we are going to save the result, and then call another function like my displayer to display the result. Here you can see the example. We are having one function my displayer. Okay, with the parameter like sum. It contains document dot get element by id. How to get that element by id? In bracket demo dot inner html is equals to sum. So this is the html file we are going to include here. We are going to get that element by id. Okay, so we are having another function like my calculator having parameters number 1 and number 2. So in this function, we are going to calculate, we are going to add the number like let sum is equals to number 1 plus number 2. And we are going to return that sum. Okay. And we are going to close the body of my calculator function. We are going to save the result into sum. Okay. Now we are going to call another function like here we have to call that my display function to display the result. So we are going to display the result like let result is equals to my calculator 5 comma 5. Here we are going to pass the value to that my calculator function, and here you can see we are going to call my display function and we are going to display the result here. That result contains the parameter and we are going to add that numbers. Okay, so this is the way we can control this sequence of that code here. So or we can call the calculator function, that is my calculator, and let the function call the display function, that is function. Here now we are going to use uh, callback here. Okay, so here you can see we are having function my display. Okay, then we are having function my calculator. In that function we are going to pass having some parameters like number 1 and number 2, and we are going to add these numbers by like let sum is equals to num1 plus num2, and here you can see we are directly displaying the result of that summation. Okay, like my displayer inside the bracket sum, and at after that we are going to pass the values to that my calculator function. In these two examples, this and this, you can see that the problem with that first example is that we have to call two functions to display the result. Here you can see in the first example, you can see we have to call two functions to display the result, like here my displayer, and here first we are going to use that my calculator function, and after calculating this we are going to save the result into one variable, and we are going to then call my displayer function to display the result. That means we are going to call two functions for displaying the result. Okay. So and in this example, in the second example, the problem with this, that we cannot prevent the calculator function from displaying the result, because we are going to write that my display function inside that my calculator function. Here you can see we are going to call that my display function inside that my calculator function. Okay. So how callback works here? So that we have seen that callback is a function passed as an argument to another function. That means callbacks are the fundamental elements of writing asynchronous JS code. These are the fundamental elements of writing asynchronous JavaScript code. So however, they have many flaws, and programmers needs more reliable and clear solution for that. Whenever you are going to create a piece of code that does something asynchronously, that means fetches data from a server, reads a file from a disk. Okay, so you probably don't want to wait until that process ends. So preferably leaving the code instructions that will be called later, those are called as callbacks. That means call me back when you finish with your execution. Okay, that is the callbacks here. So we have seen that example for calculation of numbers, that is using a callback. You could call the calculator function like my calculator with a callback, and let the calculator function run the callback after the calculation is finished. Like this, here you can see the example with calculation of numbers with the callback, like we are having function my displayer. Okay, then here function my calculator number one, number two, and my callback. My callback is another function. We are going to pass this my callback function as an argument to this function my calculator. Here you can see the body of that function my calculator contains that let sum is equals to number one plus number two. Now my callback will contain the sum variable, that is that my callback will print the addition of this number one plus number two. Okay, so here after executing this, here you can see we are going to pass the value like my calculator 5 comma 5. These are the values for number one and number two, and my display functions. Here you can see my display functions we are going to pass as an parameter to my calculator function. Okay, now this is the callback. Here you can see that my displayer is the name of function. Okay, my displayer is the name of function, and it is passed to my calculator as an argument. Here you can see we are going to pass this my displayer function as an argument to my calculator function. That is the callback. My displayer is the callback here now. Okay, so when you pass a function as an argument, remember not to use parentheses. Here we haven't used any parentheses for my displayer function. In this way, this is the right way to write. Like whenever we are going to pass any function as an argument, we have to write like this. Okay, not like this. Don't give parentheses to that function. Whenever we are going to pass that function as an argument, remember that not to use parentheses. Okay, so when to use these callbacks? So that callbacks are generally used when the function needs to perform events before the callback is executed. Callbacks are used when function needs to perform some events before that callback is executed, or when the function does not have meaningful return values to act on it. So like it is the case for asynchronous JavaScript based on timers or some request, HTTP request. Okay. So at that time we can use callbacks. Okay. So that's it for today's session. We will stop here. Thank you.